Fine. Now IPv4 completed. IPv6. Have you any idea about IPv6? Huh? 128-bit. Actually, there is a requirement of too many IP addresses. Too much IP address is required for the proper development of IT infrastructure in all over the world. Now, we cannot talk about all over the world. We should talk about universe. Because our network is not only on this planet, we are trying to, yes, we are trying to establish another planet also. Our satellites are moving around that planet, our Earth. Okay, fine. So in future, there will be too much requirement of IP address. Right now, we are using internet, IoT, many automation related things. So IPv4 is now exhausting, or it is already exhausted. Now we have requirement of too many IP address. That's why IPv6 was launched in 2012. Its exact date is 6th June 2012. Fine. IPv6. IPv6. First of all, launched in 6th June 2012. Fine. In IPv6, there are many new things. Okay, fine. It is just copying few things of IPv4, but its concept at some points are very different. Fine. So now we are going to discuss about few points of IPv6. First thing, in IPv4 we have used decimal number, but IPv6 is based on hexadecimal. Fine. Based on hexadecimal. Fine. And now in IPv4, 32 bits are used. In IPv6, 128 bits are used. Fine. And these 128 bits are divided into 8 groups. Fine. And in each group, there are 16 bits. Divided into 8 groups. And each group has 16 bits. Fine. Next point. It supports unicasting, multicasting, and anycasting. Supports unicasting. A unicasting supported by IPv4 also. Unicasting, multicasting, and anycasting. In IPv4, we have seen that IPv4 supports unicasting, multicasting, and broadcast. But there is no concept of broadcast. In place of broadcast, any casting technique is used. And in any cast, a specific IP address that is known as linked local IP address is assigned to every node. And if that node requires any broadcast like thing, that node can broadcast with its own specific IP. Okay. In case of IPv4, in every network there is a broadcast address, but in case of IPv6, there is no any network IP, there is no any broadcast address. All IP addresses are valid. Fine. So to broadcast any message, there is a specific IP in a network. By using that IP, any node can broadcast. That is the last IP address in case of IPv4. But in IPv6, every node has a specific IP. Every node has a specific IP. Because there is no concept of any broadcast IP address. All IP addresses of any network are valid. That address is used for broadcast like thing, and that is known as anycasting. Fine. Up. Now, next point. Supports approx 3.4 into 10 to the power 38 IPv6 addresses. Fine. Yes, more than trillion. Too much means you can say, okay, 3, 4, and 37 zeros, because this is a scientific notation. 3, 4, then 37 zeros. Fine. Now, this is a too long number, but you can just think about this number, that there are too much IP address. If you will start dividing this IP address to every person of the world, you can give everyone 50,000. 50,000 means simple world population into 50,000 means everybody can get 50,000. Sufficient? But developers, launched into 6 June 2012 by IETF. IETF means Internet Engineering Task Force. As per this organization, this IP will support you for next 50 years on. It will again exhaust. Getting? Fine. Now, no network IP, no broadcast IP, and no broadcast IP. All IP addresses are valid. Fine. Now next. there is no class. In IPv4, there are five classes, but in IPv6 there is no class. Okay. Now, please note down these points. Now I'm going to explain the format about or format of IPv6. Note it down. Fine. Now see. Okay, fine. These are few points about IPv6, but what is IPv6 is not clear. Okay. So now see. Fine. How many bits in IPv6? 128. How many groups? 8 group, or in each group 16 bits. 1, 2, 3, 4, 5, 6, 7. Means 1, 2, 3, 4, 5, 6, 7, 8. Done. And in every group there are 16 bits. Total 128. Fine. But IPv6 is represented into hexadecimal number. So how we will use this number? Okay. So in hexadecimal, there are total 16 characters, 0 to 9, and then A to F. Total 16. To form 16 numbers, how many bits are used? Suppose you have to form 16 numbers. 16 number आपको बनाना. Then how many bits will be used? See, suppose you have 1 bit. Means you can form 2 numbers, because we always use this formula 2 to the power n. If we have 2 bits, in that case 4. Simple. Fine. Now if we have to get 16 values, means now this is available. Now you have to find it. 8. 4. 4 bit. If I have 1 bit, I can form 2 numbers. If I have 2 bits, I can form 4 numbers by using this formula. So now the question is, if I have to form 16 numbers, how many bits are required? 4 bits. Means using 4 bits, we can form 16 different numbers. And in hexadecimal number, there are 16 characters, 16 different numbers. Means to represent a single character, single hexadecimal character, we have requirement of 4 bits. Now in each group there are 16 bits. Means how many hexadecimal characters you can form? 4. Simple. For 1 character 4 bit, it means the total character will be 4. 5. So in IPv6, 4 hexadecimal character can be formed by using 16 bits. And now then the first value will be all 0, because hexadecimal also start with 0. Fine. Then just assume what will be the last value. 4 times f. Yes. Fine. This will be the last value. This is only for 1 group, and this condition will be applied for this group, this group, this group, means all groups. It means this shows that कि IPv6 can be started from this okay, and the last value will be FFF, all F, that's I'm writing in short, all F, all F, all F, all F, all F, fine. So now this is the format of IPv6. Now, okay, fine, this is format, this is the first value, this is the very last value. But how we will use this number? Now take value of this group. Suppose its first value will be 4 times 0. Then the just second value will be 1. Then next 2, 9, A, B, C, D, F. Then after this, now I have this value 1. 0. Then 11. Means 1 1 1 2 1 3 1 F. Then the next value. Very good. 0 0 2 0. Then last value will be 2F. Then again, in this way, we will reach to this point. Now the next value will be 0 1 0 0. Definitely. In this way, the last value will be fine. Excellent. This is the first batch which has given me idea how IPv6 number will move from one number to next number, next number to next number, next number to next number. Fine? Yes. Okay. Now, just see one thing, important. There are 16 bits. If you will start counting from this value to this value, how many numbers will be there? Total from 40 to 4F. Its calculation is simple. Yes. There are 16 bits. Just put 2 to the power 16. Its value will be 65,536. Yes. Means by using only one group, we can form 65,536 different IPv6 address. Okay. Now, if I am going to use these two groups to form host, in this case, what will happen? 65,536 into 65,536. Now I am going to use this group also. Then again 65,536. Now I am going to use this group again. 65,536. Actually, in IPv6, first 4 groups are used to define different networks. Means these bits are known as network bit. 64 network bits and rest 64 bits are used to form different hosts. That's why these are 64 host bits. Any issue? No? Fine. By default, in IPv6, First 64 bits are used to represent different networks, and last 64 bits are used to represent different hosts in a network. Fine. In IPv4, we have seen that in class A, 8 bits are used for network, rest 24 bits are used for host. In class B, 16 for network, 16 for host. In class C, 24 for network and 8 for host. There are variations. Yes. But in case of IPv6, there is no any variation. First 64 bits will be used for network and last 64 will be. Now, concept of network bits should be clear. By changing a single value in these 4 groups, we can form different networks. And by changing the value of this group, we can give a unique identity or IP address to different node. Means by changing the value in this group, we can form finally different V6 IPv6 addresses. Clear? Okay. One more thing. There is no concept of subnet mask. There is no class. There is no any concept of subnet mask. Because in case of IPv4, we have seen that whenever we give an IP address, at the same time we should provide subnet mask also. Yes. But in case of IPv6, there is no subnet mask, and in place of subnet mask, we use subnet prefix length. Subnet prefix length. Yes. What is subnet prefix length? Subnet prefix length. Fine. What is subnet? Subnet prefix length means number of network bits. And this number of network bits is by default 64. This is 64. And this 64 value is used in place of subnet mask. Suppose you are just giving some IPv6 address like ABCD, something. Now, just below this IP address, you should write 64. This is IP prefix length. This shows that, okay, fine, in the above IP address, there are 64 network bits. Fine? Clear? In subnet, in case of IPv4, in subnet mask, what we have seen. Suppose there is a class A, and in class A, default subnet mask is 255. And when you will convert it into binary, then 8 times 1, then 8 times 0, 8 times 0, 8 times 0. So how many ones? 8. Fine. And what is this 8? This is network bits. Now, in case of IPv6, we directly write network 64. Simple. In spite of writing a long number, we can write just a number of network bits, and that is known as subnet prefix length. Clear? Now, these are few concepts of IPv6. Now, I will discuss some more concepts of IPv6 in next class. Then we will use it at different machines, and then we will communicate those machines. Fine.